Okay, so we're going to start off again just with triangle terminology. And now if I'm talking about this angle right here, we call this line the side adjacent. And then this line would be the side opposite of the angle. And this is always called the hypotenuse. Okay, so inversely, if I was talking about this angle up here, this one, then these change, right? These will change to this being the side opposite. And this is the side adjacent. Because anytime we do trigonometry, we will use these formulas. And as you can see, they have the opposite in there, the hypotenuse, adjacent, hypotenuse, opposite, adjacent. You will always be given two variables. And then you look at your two variables, and that's when you will decide which formula to use. Pretty straightforward. Okay, so anytime you figure out which two you have, then you can decide which formula to use. Come on, pen. There you go. For example, okay, for example, so I want you to get out your calculators here, please. Get your calculators out. For example, if I had this, if I'm talking about this angle right here, and I had a number of 1655 for that number and 435 for that number, and I want to find the angle. So the angle is always about the sine, the cosine, and the tangent. That's always the angle, okay? These are representative of the angles. So this one, then 1655 has to be the side adjacent. 435 is the side opposite. So I look at my formula triangles and I see which one I have the adjacent and the opposite. So there is the opposite, there is the adjacent. I'm going to use TOA, which is the tangent opposite adjacent. So that's just a short version for this. So I will take, it says take your opposite, 435, and divide it by your adjacent, 1655. And if you do that on your calculator, you come up with a number, 1655 here. You come up with a ratio, and the ratio comes out to 0.2628, correct? Then to get what the angle is, because this is just a ratio, we need to get the angle. You're going to go shift on your calculator and hit the tangent button. Shift tan. So hit the shift tan button on your calculator, and it will give you an angle of 14.7 degrees. And that's how we do that. Anytime you come up with a ratio of an angle, you have to do the shift. And that's really called cotangent to get the angle down. I think we need to do a bunch more of these. Let me just get rid of these circles that are on.
Doug, I got an error on my calculator. How do you fix that?
An error?
Yeah, syntax error.
So I want you to try this again then. Type in the 0.2628. and then hit the shift 10.
Yeah, it gives me an error again.
You're not using the KCO FX260 Solar 2 calculator, are you?
Oh, no, I'm not. I'm gonna grab my other one.
Yeah. You might not have to hit the shift button on that particular calculator. Probably already given you that. So let's just do another couple of examples. And I think this is the best way we're going to do this right now instead of following the ILM for the moment. We will go through the ILM, but I want to do some examples with you. So if I had this angle, and this angle is unknown, I don't know what X is, but I will give you the hypotenuse, this line, I will give you the hypotenuse as 550. And I'm going to give you the side, so that's the hypotenuse. This would be the side opposite. I'm going to give you the side opposite of 165. So the opposite is 165. So we want to find the angle. So we look at the two that we are given. Remember, you're always given two variables. So if I look at H and O, this is the one I'm going to use. You see, I have the opposite and the hypotenuse. So that's SOH or SO. So it says take the opposite, divide it by the hypotenuse, and you will get a ratio for that angle. So 165 divided by 550 gives us 0.3. And then I have to hit the shift button and sign. Shift, sign, and that will give me my angle of 17.45 degrees. Okay. So, oh, let me get my eraser here. There we go. Now we'll do a couple more examples, and I think this is important here. Get rid of these. Anytime I draw a circle, it just stays there. Okay. So what if I gave you this angle and I told you this angle was 22.5 degrees and I had a run, or I should say side adjacent.
Yep, sorry, the calculator.
Of 75. I want to know my side opposite. So I have a number, I have an adjacent that equals 75. I have an angle that equals 22.5 degrees. So what formula triangle am I going to look for? Listen, I'm given my angle and I have the adjacent and I want the opposite. So I'm using TOA. So it says to take your side adjacent 75 and multiply it, that's what multiply here, by 22.5 tan. You have to hit the tangent button after your angle. So you're going to go 75 multiplied by 22.5, hit the tan button, and then hit the equals button. And that would give me side opposite of 31.06. Does everybody get that number, 31.06?
No,
No? What did you get?
so I'm just doing 75 times 22.5, shift
10,
10.
and then hit the equals button.
Never mind.
There you go. So remember, anytime you 22.5, 10, that just gives you a number. if you hit 22.5 and hit the tangent button, that's actually going to equal 0.414, is it not? Yeah. All right. Let's do a couple more examples because I love examples. So let's say we have an angle here of 57 degrees right here. And I have a hypotenuse of 58. I want to know my side opposite. So I have the angle and I have a hypotenuse and I want the opposite. So there's hypotenuse, there's opposite, there's angle. I will be using this formula triangle. And that's what we want to do. We always want to determine what formula I'm going to be using. So this says take the angle 57-degree sine and multiply it by my hypotenuse of 58. And that should equal my side opposite. So let's do that on the calculator. 57, and then you just hit the sine button, times by 58. My side opposite should equal 48.64. Is everybody with me? You got that number? Perfect. Okay, let's do another example. So if I had this angle down here, and I don't know what x is, but I had a hypotenuse of 125, and I had a side adjacent of 37. I want to know what my angle is. So I have a hypotenuse. I have a side adjacent. Oh, that should be A. So I have a hypotenuse and I have an adjacent. So I'm going to use this formula triangle. And it says take my side adjacent and divide it by my hypotenuse. And it will give me an angle ratio. So 37 divided by 125. That comes out to 0.296. And now I have to hit the shift and it says cosine. And my angle is 72.78 degrees. So this is why triangle terminology is so important. Okay, it is. It is the reason why. Because you need to identify your two variables and then you could move on. Do we want to do more examples? Does anybody need more examples on that? One more? Okay.
One more, please.
Sure. All right. So let's say I had an angle here. Oh, I need a pen. Let's say I had an angle here at 37 degrees. I had a hypotenuse of 225.35. I want to know my side opposite. Take a minute, see if you can get the answer. So clearly, we have to use this formula triangle. We want the opposite, we have the hypotenuse, and we have the angle. So it's 37-degree sine times 225.35 equals my x or side opposite. And that comes out to 135.61. Yeah, not too bad, huh? Great.
Are these triangles given to us, or should we probably memorize these?
Well, listen, here's the acronym. SOHCAHTOA. Yes, you do get the formula triangles given to you, but this is an easy way to remember it. It's SOHCAHTOA, and you always put SOACAH and TOA, and you can just draw a triangle around these. And that's just the short version, SOHCAHTOA. Now, let's move on to your stainless steel miters booklet. And here it shows some trigonomic functions right here. They're ratios right up here. So we talked about these a little bit and how to get those numbers. So there's the acronym SOHCAHTOA right here. And then that's the formulas that we use to solve for any unknown angle or for any unknown side of a right angle triangle. So in these examples, it shows how to use that particular formula, and whatever one you want, you simply cover it up and do the operations that is left over. That's what they're trying to tell you to do here. Now, I do want you to go to your IPT book. So please grab your IPT Pipe Trades Handbook and turn to section 7.
You're
I
right.
think- I think section 7 starts on page 280, I don't know, 80, 280, somewhere around there.
Yep, 280.
Okay, so there's trigonometry tables within this book. So turn to page 287, I believe, 287. And you will see a book table in here, right? You'll see a table that looks like that. And in this table that you see in the Pipe Trades Handbook, you will see the degrees, and this is the angle. This is the angle they're talking about in there. And then they give you something called minutes. Now, the angles that we talk about are based upon a clock face. And every time it goes around once, it's 1 degree. And so if you have a clock face at half, we call that 30 degrees, or 30 minutes, I should say. And 30 minutes is equal to 0.5 a degree, or a half of a degree. So this is just a little base on this. So we don't normally go more than a half a degree on any one of these. So for example, you can see on your book here, if you go 26.5 degrees, and that's what this means right here, 26 with 30 minutes. And you hit, so if you go 26.5 and you hit the sign button on your calculator, you will get the exact number of 0.4462. or pretty close, 19. So that 30 minutes, right here where it says 30, it means a half of a degree. Now, your IPT Pipe Trades Handbook has all of the degrees, starting from 0, and quite frankly, it goes pretty high. Goes all the way to 90 degrees. Okay, and it does just full degrees and half degrees. That's all the Pipe Trades Handbook does. It does full degrees and half of a degree. So 0.5. So the explanation is right there in your book about how they do that. It's a degree is divided into 60 minutes, like on a clock face. So 30 minutes is a half a degree. Now, this just shows you some examples using what I just already did. I did a bunch of examples with you. Let's have a look at objective 1 exercise. I think I have that over here. Hang on a second. Let me just pull this up over here. Oh, I don't know what that says there. Leafs have not won a playoff series since 2004. Oh, dear. Like, can you imagine? 16 years and they haven't won a playoff series at all? That's pretty sad. Sorry, Leafs fans. I'm sorry, I had to do that. So we want to just identify in here some of the terminology based upon this angle right at this point. So what is A in this triangle? Anybody see that? What do you got there?
That's your adjacent.
That is the side adjacent to the angle. That is correct. So what about B in this figure? B
Opposite.
is going to be this one. It's going to be the side opposite. And of course, C in here is going to be the hypotenuse. I can't emphasize enough about identifying your triangle terminology, okay? Because it sets us up to do these correctly. So let's have a look at this other one here. What is side A in this figure here?
Hypotenuse.
Hypotenuse. It's the longest line, and the longest line in a right angle triangle is literally called the hypotenuse. It is that travel, if you will. What about B? What is B in there?
Adjacent. Wait.
It is
These your opposite.
opposite of the angle. So anytime you want to have the run and rise, it's always, there's an angle shown and it's either opposite or adjacent to it. So C then has to be the side adjacent. Yes? Okay.
Mhm.
Excellent. So I'm going to just jump right back over to the, oops, sorry. I'm going to jump back over to the miter. Where did that page go? There it is. Let me just jump back over to the miter book here. And this is a quick objective 1 exercise out of your book. So it wants you to identify A, C, and B. So if hypotenuse is C, yes. And the adjacent is A and the opposite is B. So take a couple of minutes and finish exercise 1 out of your book. So out of your IPT book, I want you to find the numbers associated with these angles. So These are ratios of angles. So use your IPT book and fill in what the angle would be in your book. Okay, thank you for doing those exercises. Now, the next part is start talking about these cut angles for miter pieces. Listen, we're not doing miters, and miters is simply taking straight pipe and making 90s and 45s and 22.5s and whatever angle that you want. This is how they kind of go about it. So as you can see in this picture right here in figure 17, this is a two-piece miter, right? So we have a 90-degree two-piece miter, excuse me. So we have to cut two pieces of pipe at a 45-degree angle, and then we put them together to make the 90. And then they would weld this up. They would weld this 90 up, and then they manufacture these joints. And they're called miter joints because we cut the pipe to miter them together, okay? So that's what those are called. And so I want you to go, well, we're going to have a look here at this cut back and layout. Okay, so this layout here shows us that we have a required measurement, and that is in there. Now, you would do your wraparound to get that perfect straight line right in this area. So what happens is we have to calculate what the cutback is. And the cutback is measurement A. And then you would take your cutting torch and cut along that line. So if I was to tell you that the diameter of this pipe is 4.5 inches, okay? 4.5 inches. And I'm going to give you the angle of this. So I'm going to just make this a little bit bigger here. I'm going to make this just a little bit bigger right there. And if I told you that this angle right here was 30 degrees, okay? Now you can see I have a triangle in here. Where's my red? There it is. You see I have a triangle in here, a 30-degree angle, and that angle is right there, that 30-degree angle. I want to know what my length of my cutback is to the nearest 16th of an inch. Can you guys figure that out? Well, listen, I can get the length of this line, could I not? If I know my diameter here is 4.5 inches, what is the length of this line right here?
Would it just be your radius?
2.25.
2.25. That is correct. Yes, it's the radius. So this is 2.25, and I have a 30-degree angle. So I'm going to say that the 2.25 is my side adjacent, isn't it, to the angle? And I want to know what my side opposite is. So I would have to use the formula triangle TOA, because this is what I have, this is what I want to know, and I know what my angle is. And it says take the side adjacent. So we need our angle, so that's going to be 30-degree tan, and multiply it by my side adjacent right here, which is 2.25. And if I did that on my calculator, I come out to 1.299. Yes? And now I can make this a fraction by, this is 1 inch, and I have the 0.299, and I want it to 16ths, and I times that by 16. That's going to come out to 4.78. So I round up to 5/16. There's my answer for A. My cutback is 1 5/16. So if we move forward within this ILM, you can see now how they can determine the miter pieces and the length of these pieces by finding out what your radius is, because we will find out, or we will know what our angle required is. We could find out our radius, we divide it, and then we can get our lengths of pipe after our cutback angles, etc. And that's how they do a miter fitting for steam fitters. But we're not steam fitters, so we are not going to do miter fittings. And as you see here, there is the example I just went through with you.
Could you imagine doing that with ABS fittings?
No. Because you can't butt weld ABS, right?
You can try.
No, I would not suggest that.